Okay, Kavya, you can start now.
Okay, ma'am. First of all, hi. It is my second project, which is a cloud native deployment of PHP Quiz App using EC2 RDS, S3, Terraform, and GitLab CI/CD. I will explain my project in my architecture diagram. So basically, my project is like I'm going to deploy a quiz app, which is basically uh, like a PHP quiz app. I'm going to deploy in my EC2 server. For this, I'm using RDS MySQL as my backend, and to store my remote state, to store my TF state files, I'm using S3 as my backend. So it is my architecture diagram, and also I have used CloudWatch to monitor my EC2 servers CPU utilization while using my application. And then it is my folder structure. Uh, root folders consist of main variables and output.tf files. In this main.tf, I have given that particular modules path and what it is going to do, and the necessary steps I have given here. I will explain in this main code. And bootstrap is like initial setup before going to implement my main infrastructure. What are the things I have mentioned in my bootstrap folder will execute first by giving them in manual way. So the modules folder consists of the infrastructures which I am going to implement. For those, for this VPC, I have given the scripts to create a VPC with a particular security group. Like this, I have implemented this. So I will explain this in my code. And then first one is provider.tf. It is like which provider we are going to use, at which region we are going to use. So I have mentioned AWS as my provider, and region is uh, Ohio region, this one. And then in root folder, the first one is main.tf file. In this file, I have uh, some modules like um, in my module folder, I have separate script for VPC creation. So I am declaring here that path is given, which path, like inside the modules folder, I have script for VPC creation. So what are the things I have to create is declared here, like CIDR, public subnet, and private subnets. VPC CIDR, it is a classless interdomain routing, like up to how many range of IP address this VPC can access is given here. And then we can declare this values in variables.tf file. So I am just declaring like this. Then public subnet is for EC2 server, and private subnet is for RDS creation. So we have to deploy that. We have to create RDS in two availability zones for high availability. And then next module is security groups. I have written a separate file for security group for both VPC and EC2. So I have mentioned the path in this line. So which VPC we are going to use, that particular ID of the VPC. Then module EC2 in this same as like that path is given, and then which VPC we are going to deploy this EC2, and then in public subnet we are going to deploy the EC2. So I am giving that ID, then key pair value for SSS connection, then which security group I'm going to use, and then RDS endpoint. RDS endpoint is like a host name. By using that host name, we can able to connect to that particular database. Then these two are that like database's username and password for secured connection. Then the next module is CloudWatch. Same, this line indicates the path. Then instance ID, which server I'm going to monitor. Then that instance ID. Then notification email. When my server CPU utilization reaches my limit, which I have set in that CloudWatch script, when it reaches that limit, it will give a notification like SNS notification email to this particular email ID I have given. Then module RDS. RDS is same as like that. The path is given, and then in which subnet I'm going to place this RDS. So which subnet this line indicates that ID private subnet A and private subnet B. That ID is stored here. Then which subnet group? By using that subnet group, we can allow that permissions, then username password, and then database name, which in this name I'm going to create a database. So this is main.df, and then variables.df. This is main variables.df. In this I have declared which variables are I'm going to use, just simply declared, and then for this variables I have given the values. So this is terraform.tf. In this file, I have given all those values, exact values for that variables. This is backend.tf. Uh, this is backend.tf. Like we are going to create a bucket to store our state files. So by local we can able to access the state files, but when we are going to deploy in a cloud platform, the cloud won't understand that what are the state files if we didn't store any state files in particular location. So I'm going to use S3 for this remote backend to store my TF state files. So this line indicates my bucket name, and then I have created. Then key is like a location. In this path, I'm going to store my TF state file. In this region, particular region, I'm going to deploy. Then dynamo table is like when two users are giving the command like terraform apply at the same time, it won't apply because it is locked. Like that concept, when one person is using, another person can't able to log in or create, so it is completely encrypted is given here. Then output.df, when the infrastructure is completely created, then it will give EC2's public IP as output. So by using that IP, it is just for understanding purpose. And then Bootstrap folder. Um, I have mentioned that Bootstrap is like a initial setup. Before creating the main infrastructure, I'm going to create first this infra first, because we are going to store the state files. So for that, we have to create S3 bucket and DynamoDB before, because in this I have mentioned same provider and region, and then it is S3 bucket. Uh, so we are going to create S3 bucket. Then it is a name which I am going to uh, use in this Terraform for this S3 bucket, and then it is a bucket name. So this line indicates that when I going to destroy that bucket, it will destroy the entire bucket, because inside the bucket we have that state files. It won't mind it because it will directly destroy that bucket. So I am giving this line, and then it is a DynamoDB script. For in this name, I'm going to create a DynamoDB table. It is, I have previously mentioned, for when two people are using the same command at a time, it will lock. So this is given here, and then billing mode is like when the table is used, the billing will start. Neither it can't take any billing. Then hash key is like lock ID. It will lock someone is using at the same time. Then attribute is log, the type is string. Then modules folder. In this modules folder, every like VPC security group, every infra has separate folders. Like inside VP's folder, main.tf, as we mentioned in the root folders, inside the VPC main.tf, I am declaring the CIDR block, and then internet gateway for internet connection, and then private subnet for EC2, and then public subnet for EC2, and then private subnet for RDS. So I simply mentioned which VPC I'm going to use, then availability zone, and then this map public IP on launch will give a public IP address for public IP for the servers. So then same as like that for private subnet B for RDS, and then we are going to route, and then the route table is created and the route table association is also implemented, so we can successfully able to connect via public server to the internet. So it is a process. Then variables.tf, in this variable.tf I have mentioned the variables, and then output.tf I have given vpc id, subnet id, and private subnet ids, so I can able to see that ids here. Then it is security group. Then for example, if we are going to use a ec2 server, we can't able to connect to that server initially. We have to give some security groups. By using that port we can access that server. So I am here declaring from port 80 and from port 22 I can able to communicate, that is given here. And then this will states that whoever can access this ec2 server. So this is inbound and then this is outbound, incoming traffic and outgoing traffic basically. So I have mentioned the rules here. And then it is it is a security group for RDS. Only from this port 3306, which is basically a MySQL communicating port, only this port we can be able to connect. Otherwise, we can't able to connect. So, like only from this EC2 server we can able to connect to that RDS, like our database. So I mentioned here. Then variables.tf, what are the variables we need? We are giving here, and then output. In this, I have given the security group ID and then RDS subnet group ID, and then it is RDS main.tf. In this, I have created the subnet group first of all. Um, then AWS DB instance. In this part creates a database. So for that we have given a storage like which engine MySQL or PostgreSQL or whatever the database we are going to use, we have to mention here, and that's version and instance class and the username password we are going to use. Then DB name, and then skip final snapshot. I have mentioned it as true. So because I don't need any snapshots or backups. And then which VPC security group, and then subnet group name. Uh, Lastly, it is a tag only. Then simply it creates a database first of all in that name, and then variables. What are the variables we are going to use? Then output. Then same as like that EC2 main.tf. In this, I have created the EC2 which AMI is going to use, instance type, then which subnet like public subnet, then which VPC key name, and then this is the major part, user data. In this user data, I have used the template file. Inside this path, I have the file userdata.sh.tpl. It is a template file. Like inside this file, I have given the configuration like index.html and CSS and how to connect to the database. I am giving these as input to that file. By using this, I will show this later. Then this is the userdata.sh.tpl file. Inside this file, first of all, uh, I'm giving this set of commands like the shebang line. Then it is like we are going to install the Apache server, and my application is based on PHP. So we are going to install the sufficient packages related to PHP, Apache, and then we enable the Apache server and we start the Apache server. Then this line indicates that it will remove the default Apache page. Then config.php. Inside this location, that is Apache path, we are going to create a config.php. Inside this config.php file, I have given this set of lines like we are going to create a database and how to connect to that database. In this line, it will take the input from that these lines uh, as input RDS endpoint username and DB password, and then by using that it will connect to the database. If it is not if it is not true or if it is failed, it will give connection failed message. Then this line indicates it will create a database. If it not exist only, if then it will select that our database what have been created. Then inside this database it will create a table called results. So basically my quiz application is like when a user enters my application, they have to give a name and they have to answer for set of 10 questions, and then they submitted that quiz. Then next page it will show that score for that user. So for that we are going to create a results table to store the scores. So it is created in this set of lines. And then index.php, I didn't mention my HTML CSS code, but I have created because it has a bunch of lines. So in this HTML CSS code, I have designed um, as per my decision. So then submit.php. In this submit.php, I will submit all the data which is given in the application, then for every user. So this line indicates that every user's name will be converted into lowercase and then prevent resubmission. So in my application, when I give some name ABC and I have given the answers after that, I can't able to log in that application with the same name. So to prevent that submission, I have given some SQL queries here, and then I have given the answers for the questions setted here. And then when the users will give the answer, it will store here and it will compare with the original answers, and it will give the scores. So finally that score will insert into the results table. Then variables.tf for these files, and then output is public IP of the instance, and then instance ID will be shown. Then this is cloudwatch main.tf. It is like we are first going to implement CloudWatch means we have to set up the SNS. So then for SNS we are going to create that resource AWS SNS. So to give CPU alert. So in the name of the CPU alert topic, I have given the tag, and then we have to first of all we are going to set up a CloudWatch, and we are creating SNS means we have to subscribe that particular mail to receive that uh, alert message. So for this, subscribe your email to the topic. So in this module, I have creating the subscription email alert. So topic ARN Amazon resource name. So I'm simply giving my notification email to receive the email notification alerts. And then in this part, I'm declaring the range, like my CPU will reaches this utilization. I will receive a particular mail alert to prevent any failures. So it is given here set of lines, and then variables.tf for this CloudWatch. And finally, I am setting a YAML file to automate all these files via GitLab. So this is my YAML file, and I will explain this. These two line indicates that it will take the default Docker image uh, to to execute all these processes. So I mentioned here, and then entry point is like it will able to this will allow us to run all bash commands. So then I have these set of stages here: bootstrap, validate, plan, apply, and destroy. Then variables. Inside the root folder, I have all the important files. So I have mentioned here. Then bootstrap is like I'm going to run this as manually because it is an initial setup. So I will given this as manual setup. So inside the bootstrap folder, it will give the command terraform init and then it will apply. It will create a S3 bucket and DynamoDB table. It is all the manual process. If it fails, it won't allow to the next pipeline stage. So I given as allow failure as false. Then validate. Inside the root folder, it will give the init command validate. To validate, it first of all needs the bootstrap uh, process. So I have given this as needs bootstrap. Only bootstrap is executed, the validate function will execute. Then it is a plan stage. In this plan stage, inside the root folder, we have to reconfigure because it will remove the existing caches and it will start as a fresh command. And then in this planning stage, it will stored in the TF plan. So it is stored in a path called artifacts. It is like it is stored in a particular place and then apply. It is same as like that. It will created the entire infrastructure and then it needs plan. Only the plan gets executed successfully, apply will execute. So in this case, I have given apply also as manual for understanding purpose. So finally, destroy. So I will show my. This is my Git repo, and I have given here. So we are going to run my pipeline. So as I mentioned earlier, Bootstrap is like a manual setup. So you have to run this in manual way. So it will take some time. Only the Bootstrap will executed. We can able to run all these pipelines. So it is like this. It is written in YAML file. So my Bootstrap stage is successfully completed without any issues. So it will create, now it creates my S3 bucket and DB table. So next it automatically triggers the validate stage. So it is running now. So validation is also successful and then planning stage is now triggered and it is running. Validation is also successful. So next planning stage is also successful. Then we have to trigger the apply stage because I have mentioned this as manual action. So I need to run this. So from this, all the infra plan has been executed. Now the real main infrastructure is creating now. So it is creating the entire infrastructure. So parallelly, I got a mail. Like I have mentioned in Cloud Watch, to confirm the subscription only, we can able to receive the email alert. So I have subscribed. So our process is running. So it is creating all the infras. So it is creating the entire infrastructure. It's going to be in. So yeah, my pipeline has been successfully implemented. So we can able to see our application live now. So the entire infrastructure has been created. So it is my server. So we can able to see our application now. By giving the public IP in the browser, due to my internet connection, it took some more time to display my application. So yeah, I got my application live now. So if I enter my username as ABC, and the timer will start. So it is basically a quiz application. So we can able to answer now. Then I can able to answer for these questions. So, so I have answered all the question and still it remains for 20 seconds. So I will submit my answers. So I by this username, my score is visible here. So this was my entire project. So if I trigger my EC2 by giving some comments, I can able to receive the email alert also. So it was my entire project. Thank you.